To determine the safe number of circuits for a 15 kilowatt generator, it is crucial to ensure that the total amperage drawn by all circuits does not exceed the generator's rated amperage. The generator is rated at 50 amps, 3-pole, 4-wire, 125 volts/250 volts. To calculate the safe number of circuits, we need to consider both 120 volts and 240 volts circuits, as well as the presence of motor circuits. For 120 volt circuits, we divide the generator's amperage by the nominal voltage. This gives us 50 amps divided by 120 volts, which equals 0.42 amps per circuit. This means each 120 volt circuit can safely draw up to 0.42 amps. Next, for 240 volt circuits, we perform a similar calculation. We divide the generator's amperage by the nominal voltage, resulting in 50 amps divided by 240 volts, which equals 0.21 amps per circuit. Therefore, each 240 volt circuit can safely draw up to 0.21 amps. Motor circuits require special consideration because they typically draw significantly more amperage during startup than during normal operation. This inrush current can easily overload the generator if multiple motors start simultaneously. It is essential to minimize the number of motor circuits that can operate at the same time. Based on these calculations, we can determine the safe number of circuits in various configurations. Firstly, considering only 120 volt circuits, you can have up to 120 circuits, provided each circuit does not exceed a maximum draw of 0.42 amps. Secondly, if you opt for only 240 volt circuits, you can safely operate up to 240 circuits, with each circuit drawing a maximum of 0.21 amps. Thirdly, a mixed configuration of both 120 volts and 240 volt circuits is possible. You could have up to 120 volt circuits and 240 volt circuits, adhering to the amperage limits calculated earlier. However, it is critical to limit the operation of the three motor circuits to separate circuits to prevent overloading the generator during startup. To illustrate with an example, let's consider a scenario with a combination of 120 volts lighting circuits, 240 volts heating circuits, and motor circuits for a refrigerator and freezer. Let's assume you have 120 volts lighting circuits, each drawing 1 amp, totaling 20 amps. You also have two 240 volts heating circuits, each drawing 5 amps, totaling 10 amps. Finally, you have two motor circuits, one for the refrigerator drawing 8 amps at startup and 2 amps running, and another for the freezer drawing 10 amps at startup and 3 amps running. The total running amperage would be 20 amps for lighting, 10 amps for heating, 2 amps for the refrigerator, and 3 amps for the freezer, totaling 35 amps. This falls within the generator's 50 amps capacity. However, during startup, the refrigerator and freezer could draw 8 amps and 10 amps respectively, in addition to the 30 amps already in use by the lighting and heating circuits. This would result in a total of 48 amps, which is close to the generator's limit. If both motors start simultaneously, the generator could be overloaded. To mitigate this risk, consider staggering the startup of the motors or using soft starters to reduce the inrush current. Another important factor is to consider the continuous load on the generator. Generators typically have a continuous rating, which is the maximum load they can sustain for extended periods. Exceeding this rating can lead to overheating and damage to the generator. Refer to the generator specifications to determine its continuous rating. Always consult the generator's manufacturer's recommendations for specific circuit limitations and safety guidelines. These recommendations are crucial for ensuring the safe and efficient operation of the generator. It's also important to avoid connecting excessive loads to the generator, as this can not only damage the equipment, but also void warranties. Regular monitoring of the generator's output amperage is essential to ensure it does not exceed the rated capacity. This can be done using a clamp meter or by observing the generator's built-in ammeter if available. The goal is to maintain the load within the safe operating range of the generator to prevent damage and ensure a reliable power supply. When planning the circuits connected to the generator, it's best to prioritize essential loads such as lighting, refrigeration, and heating. Non-essential loads like air conditioners or electric heaters should be used sparingly or avoided altogether to conserve the generator's capacity. It's also a good practice to use energy-efficient appliances and lighting to reduce the overall load in the generator. LED lighting, for example, consumes significantly less power than traditional incandescent bulbs. Consider using a load management system to automatically shed non-essential loads when the generator approaches its capacity. This can help prevent overloads and ensure a stable power supply for critical equipment. Regular maintenance of the generator is also important for ensuring its reliable operation. This includes checking the oil level, cleaning the air filter, and inspecting the spark plugs. Refer to the generator's owner's manual for specific maintenance recommendations. When operating the generator, ensure it is properly grounded to prevent electrical shock hazards. Use heavy-duty extension cords that are rated for outdoor use and are in good condition. Avoid overloading extension cords, as this can cause them to overheat and create a fire hazard. Never operate the generator indoors or in an enclosed space, as this can lead to carbon monoxide poisoning. Carbon monoxide is a colorless and odorless gas that can be deadly. Position the generator outdoors in a well-ventilated area, away from windows and doors. Store fuel for the generator in a safe location, away from heat sources and open flames. Use only approved fuel containers and follow all safety precautions when handling fuel. In summary, determining the safe number of circuits for a 15 kilowatt generator involves calculating the amperage capacity of both 120 volts and 240 volt circuits, considering the startup current of motor circuits, and adhering to the generator's manufacturer's recommendations. Regular monitoring of the generator's output amperage and proper maintenance are essential for ensuring safe and reliable operation.